So as we know that air is a mixture of different kind of gases. The gases which already we know that. What is the gases present in air? All of you? What is that? What is the gases present in air? Yes?
Oxygen, nitrogen.
Oxygen, nitrogen, carbon dioxide, and as well as argon. And of course, it contains what? Dust particles and as well as water vapor. Now, these components, if you take like nitrogen, argon, oxygen, and all, their boiling point difference is less than 25 degrees Celsius or Kelvin. So that is why we will implement a technique called as fractional distillation to separate the individual components of air. Now, that is what, as we know that separation of components of air, if you want to know, first of all, you need to know how this process will take place and what is the industrial technique we can use. Even I will show you the real industry unit, how that it will be taking place and all. Now, if you notice, if you take this boiling point and what is the percentage they are present and all. As we know, what is the percentage of nitrogen they are present? What is the percentage of nitrogen in air? 90. What is that? 78%. Oxygen 21%. Like that we can see. So separation of the gases of the air, whatever it is present like nitrogen, oxygen, argon, carbon dioxide, helium, neon, krypton, xenon, all these things are present in the air. So the major component of air in nitrogen is nitrogen, which is present approximately 78.03%. What is the percentage? 78.03. Now, if we take oxygen, oxygen is around 20.99% is present in the atmosphere. And same way, if we take the third major component of air is argon. What is the first one? Nitrogen. And the second one is what? Oxygen. And the third major component is called as what? Argon. Understand everybody? So this argon is present in 0.93%. What is the percentage of argon? 0.93%. So like see majority of this one. As we know now, carbon dioxide is present 0.03% and etc. etc. Now, these are the major components of air, so which we are going to separate it today, and we are going to see that how they are obtaining what is the things and all. So now you can see all the remaining gases of air, they constitute only very less percentage, and that percentage we will consider even it is 0.05% remaining all the gases. Now let us comes to here. Nitrogen, if you will take it, why we should separate it? That is the first question. Now, Mithakshi will ask, sir, you are saying nitrogen, what is the necessity of separating of nitrogen? So, what is the necessity of separating nitrogen? Anybody can tell me where we can use the nitrogen? Where we can use the nitrogen? Anyone, please? Where we can use the nitrogen? Hey, open your mouth. You're 9th class, ra. Open your mouth. Nitrogen, where we can use? We can use in production of fertilizers. Do you understand, all of you? Next, you can take oxygen. Oxygen is used in making where? Oxygen is used for breathing purpose. We can use hospitals, help patients having breathing difficulties, and we can use also in steel factories. Manufacturing steel in industries, we people use what? Oxygen. Same way, if we take argon, argon we can use to fill in the bulbs. Bulb, do you know all electric bulbs? Mithakshri, ready? Electric bulb. So electric bulb inside will be filled with argon because argon is unreactive gas. Simply open, not opening the mouth, there is no use, I am saying. Again and again I am saying, Mr. Kaushik and all, you can leave from the meeting, no issues. I don't want anybody. I want 1 or 2 is also enough. Those will study nicely. So nitrogen basically we can use in manufacturing of fertilizers. That is why we have to separate the nitrogen from air. Oxygen we are having in hospitals, patients and all, we people can use. And as well as production of steel in industries we can use. Same way argon to fill in the bulbs. This is general knowledge also. To fill in the bulbs, electric bulbs, because they will be, it will be unreactive one, so that it will protect the life of filament. What is the filament we will use in the bulb? Anybody can tell me? What is the filament name?
Tungsten.
Tungsten filament. Understand? So it will increase the life of the filament. That is why, because as it is unreactive gas, will increase the life of a filament called as tungsten. That is why we are using argon. Now carbon dioxide and all, as we know, we are having a lot of applications. We can use it now. Now if it comes to here, these gases, various gases of air, they are separated from one another only by one separation technique. What is the separation technique? What is separation technique?
Fractional distillation.
Fractional distillation. Do you understand, everybody? So fractional distillation, and also we people are not possible to separate into gaseous state. We have to compress the air into liquid air. Then only it is possible to separate the components. Are you understand, everybody? So fractional distillation by what air? Of liquid air. Please remember that. Write it. The various gases of air are separated from one another. The various gases of air are separated from one another. Are separated from one another. One another by the fractional distillation of liquid air. Which air? Liquid air means we have to decrease the temperature. We have to cool it or not. Mr. Reddy, Harish, we have to cool it or not. We have to make it.
Yes, sir.
We have to cool the air so that air will become liquid form. Then only it is possible to separate the components of all the air by using which technique? Fractional distillation. Now, let us take this fractional distillation. If you want to understand, we need to know the different gases of air having different boiling points, and also we need to know their boiling point difference is how much? Their boiling point difference is less than
25.
Less than 25.
25 degrees Celsius. Now, if we'll take all of you, except carbon dioxide, of course, in our NCERT book also they have given, except carbon dioxide, they have given nitrogen, argon, and oxygen boiling points. Can anybody tell me what is the gas and as well as their boiling points? Gas, suppose nitrogen you can take. So what is the nitrogen boiling point? Anybody? See the book and tell me. Liquefied gas. Yes, boiling point of liquefied gas. Liquefied gas. Liquefied gas means what? It has been liquid state. Understand, Ra? Yes, please. Understand, everybody? Now, what is the boiling point of nitrogen gas? Anybody? Minus 196 degrees Celsius. Minus 196 degrees Celsius. Next, argon. Argon, ARGON, argon. It's not there. Minus 186 degrees Celsius. Minus 186 degrees Celsius. So what is the temperature difference? What is the temperature difference? 10 degrees. It is not possible to separate by normal distillation. Next, oxygen. What is the boiling point of oxygen? Liquefied oxygen. Liquefied oxygen. Minus 183 degrees Celsius. So this is the highest boiling point, and this is the what? Lowest boiling point. Sir, what, sir? You are writing 183 and 189 and you are saying highest and lowest. But what sign it is? What sign it is? Negative sign. So negative sign, who is bigger? Minus 183 is bigger or 189? 196 is bigger. Mr. Kaushik, will you say the answer or will you leave from the meeting? Which is bigger? Mr. Arun? Johan? Kaushik? 183 is bigger or 196 is bigger?
The minus symbol is
Minus is there. So minus 183 is bigger. That is why I'm writing the highest boiling point of oxygen is minus 183. So who will separate first? Oxygen will separate first or nitrogen will separate first? Anybody? Nitakshri? Divya? Who will separate?
Nitrogen.
Nitrogen will separate.
Nitrogen.
you are reaching the temperature. Is it possible to reach the temperature? Minus 183 first will come or minus 196 will come? Mr. Reddy? Omar? When you are going down the temperature, minus 186 will come first, or 183 will come first, or 183 will come first. Yes, please. 180?
Hydrogen will go now, sir.
Hydrogen will go. Hydrogen, where it is? I never even talk about hydrogen, Mr. Omar. What are you speaking? Where are you? Are you unconscious?
Yes, sir.
Never speaking about hydrogen. Then you are saying hydrogen.
What? That only here.
Tell me, guys. So which
Sir,
one?
183.
183 will come first. So when we are separating the liquefied gases, which gas will separate first?
Oxygen.
Oxygen will separate first. Understand? Next also you can take carbon dioxide. So if you take carbon dioxide, its boiling point is minus 78.5 degrees Celsius. Minus 78.5 degrees Celsius. So to separating carbon dioxide, is it necessary fractional distillation? Is it necessary to separating carbon dioxide? That is what.
No, sir.
No, the temperature difference is more. So carbon dioxide boiling point is minus 78.5 degrees Celsius. Please learn this. Is it okay, everybody? Now, this is what the boiling point. So now if you'll notice it very carefully, nitrogen, argon and oxygen, their boiling point difference is very, very closer. Is it yes or no? Yes. So the boiling point difference is less than 25 degrees Celsius. So we need which technique to separate it? We need fractional distillation. Are you understand, everybody? So we need fractional distillation to separate the components of nitrogen, argon and as well as oxygen gas. Now strictly I'm saying those are not all opening mouth. I'm going to remove from the meeting. I don't want anybody extra other than those who are studying. Behaving like this years time, no improvement. I cannot I cannot respond to your parents. You should understand. Behaving normally as usual, there is no use. Now, let us start the process. How this air is separated into its components, that is what gases, and what is the steps is following. That is all we'll study now. So I will show you the real photo of the gases from the air, how they are separated in the fractional distillation planet. So that is what the planet unit where we can separate. Even in our India also we are having so many fractional distillation planets where we can separate the individual gases of air. So this is only called as fractional distillation column, where we can separate all the components of air like nitrogen, oxygen and as well as what? Argon, and of course carbon dioxide will come before itself. So this is what is only called as fractional distillation. Now let us see how this process will take place and what is the process, how we can separate it and all. Now the general mind map, if you want to understand how this separation of components of air will take place, first of all we have to compress the air. What we have to do, guys? We have to compress the air. Why we need to compress? Anybody can tell me? Why we should compress the air?
Sir, then it will be cool, sir.
That is what. So,
So the molecular arrangement.
that is what. To make the particles to come closer, we have to compress the air, so that compression will make to increase the fastness of the air, so that it will be cooling very, very fastly. So this is what the complete process of separation of components of air. All of you observe very carefully. We people are having air. What we are having now? Air. Now, these air, first of all, we should go with the filtration. Why we should go with the filtration? Anybody can tell me? Why we should go with the filtration? Mithakshri?
To remove dust particles.
Arun Kailash? Anybody? Why we should go with
To
the
remove dust
To
particles.
remove dust particles.
to remove the dust particles and as well as water vapor. So dust particles and as well as what? Water
Water
vapor.
vapor.
Why means, observe very carefully. What is the reason? Why we should remove the dust particles and water vapor before going for separation? That is very, very important question. Industrial question. Future you may be becoming engineer, some of you. So then what is the reason why we should filter the dust and water vapor, and as well as even carbon dioxide also we can remove, because they will become solid in the cooling process and they will block the pipes. Are you understand, everybody? Harish, ready?
Yes,
They will
sir.
become solidified. They will turn into solid when we are cooling, because their boiling point is less. So they will easily convert into solid state and they will cause us for blockage in pipes, so that nitrogen, oxygen gases and all cannot move further. That is the reason we have to filter to remove dust and then what? Water vapor. That is the first step we have to follow. We have to filter the air, then only we have to compress the air. Then if we'll compress the air, then the speed of the air will increases, and then that is what cooling process we will do. So in this cooling process, rapid expansion will take place. Rapid expansion means it will be contact with a cool water. I will show you that process, everything neatly, so that fastly, suddenly the hot air will turns into what air? Hot air will turns into cold.
Cool air.
It will be liquefied air. Liquefied means what? It will be converted into liquid state. The air is completely converted into liquid state. So see, air, we are going to compress it. Compression and cooling, so that it will be converting into cold air. By decreasing temperature, it will turn converting into what? Liquid air. Now, this liquid air, if we'll allow to warm up, through what column? What column?
Fractional column.
Fractional distillation. Then first boils. Who will boils first? Who will boils first? You can see here.
Nitrogen.
Nitrogen. Next one boils second. Argon.
Argon.
Boils third. Who will boils third?
Oxygen.
Oxygen. So if you imagine this is the fractionating column. If this is the fractionating column, so who will come down? Anybody can tell me? Who will come down? Temperature range. It will go with a 0.
Heating mantle.
Minus 183, minus 190, minus 195, minus 196. So who will come down? That is what my question.
Oxygen, sir.
Yes. So at the lower levels of fractionating column, we are going to get what? Oxygen. And the next one we are going to get argon. And top we are going to get what? Top we are going to get what? Understand, Divya? So this is only called as fractionating. So we are going to cool the air first. Later we are going to warm up by allowing into the fractionating column, so that we are going to separate the nitrogen gas, argon gas, and as well as oxygen gas. But they all are in which form? Liquefied form. Means in the sense of what? What we are going to get? Liquid oxygen, liquid argon, and liquid nitrogen will come. Is it okay, everybody? Yes, please. Respond.
Yes, sir.
Yeah. So we are going to get liquid oxygen, liquid argon, and liquid nitrogen gas will come when we are separating. So this is what the process which is we are using to separate the components of air, which is already there in our textbook also. And the percentage by volume also very important. What is the percentage of argon? Everybody, what is the percentage of argon? 0.9 percentage. And the nitrogen percentage 78.1 percentage. And the oxygen percentage, anybody?
21%.
20.99%.
20.99 percentage. And remaining all the gases 0.05 percentage only. So that is why we will use a separation technique called as fractional distillation to separate the nitrogen, argon, and as well as oxygen. Now let us see that video also. Yes, Omar, ask me.
We are separating it because they are having different boiling point, right?
Different boiling point less than 25 kelvins. Understand?
Yes, sir.
That is. But carbon dioxide is not coming here. Why? Anybody can tell me? What is the reason? Why carbon dioxide is not coming?
Because it has more difference, sir.
It is having
Because it has
more.
8 point.
It is minus 78 only. What is the boiling point of dry ice? Carbon dioxide. What I said? Minus 78.5 degrees Celsius. So carbon dioxide will come before itself. Now, if you notice it, this is what the complete process of separation of components of air. First of all, we have to filter the air. To filter what? Filter what, guys?
Dust
Dust
particles.
Particles.
Water vapor.
Vapor. Understand? So that now after that the air will be entering into the compressor. Air will be entering into the what? Compressor. So compressor, what it will do? It will compress the air so that the pressure of air will increase or decreases. The pressure of air increase or decreases. Now, if it is compressed, then it will convert into what air?
Hot air.
Hot air.
That is what, have you noticed it? Whenever you are filling the cycle tube and all air, that air which is coming from that, it will become very, very hot. Have you noticed it? Yes, please.
Yes,
Yes,
sir.
sir.
It will be hot. Why? Because of compression. If I will compress, then all the particles will be pressurized, so that due to the pressure, the air will turns into what? Air will turns into what? Hot air.
Hot air.
Now, these hot air will be rapid cooling. We will allow for a container where it contains the internal tube. You might be noticed here. Internal tube. This internal tube contains what, guys? Anybody can tell me? This internal
Cold water, sir.
what? Freezing cold water, so that whenever this hot air will come and will touch this surface very forcefully, fast absorption of heat energy will take place, so that rapid cooling will take place. Understand, Mitaksri? Rapid cooling will take place, so that the hot air will turns into what air?
Cold compressed air.
Cold compressed air, so that it will be formed into which state?
Liquid state.
Liquefied air. Understand, everyone? Liquefied air. Now, this liquefied air is entering into the separator. So separator, the first gas at minus 78 degrees Celsius, which gas will come out?
Carbon dioxide as a dry ice.
Carbon dioxide gas will come out as a what ice?
Dry ice.
Is dry ice. So a solid CO2 is called as what ice we used to call as? Dry ice. Please,
Dry ice.
a solid CO2 is only called as dry ice. Now,
Dry ice.
again, to separating the all the nitrogen, argon, and as well as oxygen, we need to send the gas very forcefully. That is why we are sending the gases remaining components with the help of expansion jet. Expansion jet means, for example, your mother asks you to pour the water or else watering the plants. You people will, if you want to send the water to long distance, you people will press the pipe at the starting. Yes or no? Yes, please. Will you people will press the pipe or not to send the water
Yes,
to
sir.
long?
Yes, sir.
Sir.
Same way. Suddenly